Namaskar. This is Mrs. Neela Kalyan Jagdare and today we'll be discussing the concept of what is closure and closed area. Yes, and what we're discussing today is closure and closed area pertaining to hydrocarbon reservoirs. Yeah. Now, this may be applied, if you're talking about closure and closed area for hydrogeology also. But today what we're discussing is basically for the hydrocarbon reservoirs. Okay, so please keep that in mind. And the reason why I am mentioning this again and again is because the two are different, that is water and hydrocarbons. Hydrocarbons being lighter in weight, yes, they float on water as the density of water is 1 and hydrocarbons are less in density. Though due to buoyancy they float up above the water. And that being reason we talk about closure and closed area in such a way that how do hydrocarbons move and in which direction they come up and where are we supposed to be drilling accordingly then. Yeah, so things we'll discuss those things later, but for today we'll understand what is closure and closed area of a doubly plunging anticline. Yeah, I have already mentioned in my previous videos. If you've checked out my videos that I made prior to this, we talked about what is doubly plunging anticline, what is singly plunging anticline and things like that. Yeah, but just a quick revision today. If we are talking about a doubly plunging anticline, what is a doubly plunging anticline? This is an anticline, this is an anticlinal fold, yes, and a doubly plunging anticline is when, what is a plunge? It is the angle made, okay, by the axis of the fold, yes. So if the axis is bending, if it is being, if it bends, yeah, this is what is a plunge. You getting me? Yeah. And when the fold is plunging on both the sides, that is the axis is folding on both the sides. Yes, this is what is a doubly plunging fold. See, please understand, these are the limbs of the fold. These two are the limbs of the fold. This is the axis of the fold. Yeah, and the axis of the fold is plunging here, this side. See, if you are seeing this properly, this is vertical. Towards your right hand side, my left hand side, the axis is horizontal. And the right side, towards my right side and your left hand side, the axis is plunging. It is making an angle. This is a singly plunging anticline. A singly plunging anticline by itself cannot form a trap. Alright? But a doubly plunging anticline, it does. See, the structure, I will not say singly plunging anticline by itself cannot form a trap. I will just say it does not have a structural closure. It may form a trap. You know why? Because if you understand things properly, if you have a singly plunging anticline like this, okay, and the structure is such that the regional dip is towards your right, okay, that is the regional dip is this side. The oil and gas will come up from here, yes, and if it is sealed properly and it is like this, the structure is like this, then the hydrocarbons will tend to get accumulated in this area. They will tend to get accumulated in this area to some extent. Okay, alright. So, however, it depends upon what is the, what do I say, how is the sealing. If it is very compact, only then, otherwise they are likely to escape. And a singly plunging anticline, otherwise what happens? And if the reservoir and if the regional dip is towards, this side, that is towards your left hand side and my right hand side, then what will happen is the hydrocarbons will come in, yes, and because this axis is horizontal, there is nothing to entrap it now, right? So therefore what will happen is the hydrocarbons will just go away. Therefore it is mostly said that singly plunging anticline by itself does not have any structural closure. Please understand, I am saying structural closure. Yes, so the structure cannot give rise to formation of a trap, but stratigraphically it can, as I am talking about the seal. If it has good seal, it may. Alright, and also a singly plunging anticline, if it is cut by a fault at the crest, at the nose of the anticline, and the fault is sealed, it is impermeable. In that case, again the singly plunging anticline will give rise to formation of a trap. Fine. But now today what we are discussing is doubly plunging anticline. So we are talking about a doubly plunging anticline like this. Yeah. So and it gives rise to what shape? This is giving rise to a domal shape. Correct? Yeah. It is giving rise to a domal shape. Right. What is closure and closed area? Closure is the vertical dimension where the hydrocarbons are retained. Yes. Or where the hydrocarbons are stored. Yes. And a closed area on the other hand is the horizontal dimension where anywhere you drill in that area you will get hydrocarbons. That is what is a closed area. The difference in between the two, if you just talking about, is closure is the vertical dimension, whereas closed area is the horizontal dimension. Yeah. So if you're talking about, basically what we'll deal with today is closure and closed area of a doubly plunging anticline. 3D, in 3D, if you've understood what is a doubly plunging anticline, it is much better and good. Why? Because see, this is a fold. Yes, this is the axis of the fold making angle on both the sides, giving rise to a domal structure. Getting me? This is a domal structure inside. Getting me? It is a domal structure. Now, what is happening is, because it is a domal structure, it is giving rise to a good structure where it will store hydrocarbons, where hydrocarbons are stored very well, properly, and they will not escape that easily, provided the seal is good enough. Again, see, for any reservoir, what are the three prerequisites for any reservoir? All right, or three elements of a trap is nothing but you need a source rock. Yes, the rock where hydrocarbons are generated, cooked. Yes, you need a reservoir rock which is porous and permeable, wherein the hydrocarbons are stored, which are coming from the source rock. Yes, and you need a seal, or the cap rock, where that seal or the cap rock helps in entrapment, or helps in sealing the reservoir, which does not allow further movement of hydrocarbons in the up-dip direction. Yes, otherwise they will just go away, right? We don't want that. We want the hydrocarbons, right? See, I'm talking to you over the phone and the polycarbides there are coming from hydrocarbons. Yes, so all of us need hydrocarbons every day, because early in the morning you get up and what the first thing you do is you brush your teeth. From where does it come? It is coming from hydrocarbons. You're getting me? Every day we need hydrocarbons in our day-to-day life. You cannot sustain without it. However, on the other hand, I do support green energy. We have to, because we are living on our planet Earth, and planet Earth, is on the verge of, increasing its temperature so high that it has lost lot many species on this planet. Yeah, just because of the global warming thing. So in order to control that, we guys have to move on to green energy. Having said that, I also tell you that hydrocarbons, especially pharmaceuticals, and in our day-to-day life, for example, the tires of vehicles, the chairs that we use mostly, there are no alternatives. See, wood, if we are saying we cannot cut trees to that extent where we cut trees and make wooden chairs and all. You're getting me? So, to some extent, though we are not willing to exploit the Mother Earth and explore for hydrocarbons and we'll have to do it. Yeah, but again, at the same time, I'm saying we'll have to do it in what way? In sustainable manner, meaning for drilling purpose. We need small. Okay, I'm going far beyond actually the topic, but as I always say, my lectures are interdisciplinary. So we may use, it is already used in the oil industry. They do use, gorgum and things like that. That is cluster beans. Cluster beans, the powder is used for, making the drilling fluids. Then you have walnut husk or even groundnut husk and things like that are used to, keep the fractures open and things like that, which act as proponents and all. Alright, please do not get confused or perplexed because of the things that I am talking. Because this lecture basically, I'm sure, is the first year students are listening to it mainly. So, but you will understand what I'm talking, because no rocket science, is all logical. Alright, fine. Coming back again to closure and closed area. Moving ahead rather, I'll say, to closure and closed area. That is, a definition of closure. Of a doubly plunging anticline, if I'm saying. See, I'm explaining in 3D, alright? See, closure is nothing but it is a maximum dip away from the crest of the anticline, in which the dip is least. Meaning, this is a fold, anticlinal fold. Where is the dip least on this fold, guys? These are the limbs of the fold and this is the axis of the fold. The dip is least on the axis of the fold, correct? Yeah? So what we are trying to do is we are trying to find out the closure And what is the definition of closure? It is the maximum dip away from the crest of the anticline in the direction in which the dip is least. Meaning maximum dip away from the crest of the anticline in the direction in which the dip is least. What is the direction? Axis is the direction, correct? Yeah. So this is the axis of the direction, and it is the axis of the direction where the dip is least, and that is why it is going down here, and like this you get the W plunging anticline, and this is what is the closure, meaning right from the crest of the anticline till here, this is what is the closure. Yeah. Closure of the W plunging anticline. Alright. And closed area. What is closed area? Closed area is, I'll just hold it like this for you guys. Like this. Closed area is anywhere you drill on this surface, you're going to get hydrocarbons. Yeah, that is what is closed area of a W plunging anticline. The closed area is any reservoir is the area where anywhere you drill you will get hydrocarbons. That is what is closed area in a hydrocarbon reservoir. Yeah, fine. If you're talking about W plunging anticline, I will just quickly draw a figure where we'll discuss about closure and closed area of a W plunging anticline. So if you're to be giving topics, just give me a moment. Alright, fine. So what we're discussing is about closed area of a anticline. Alright, fine. So if we are drawing a structure contour map for that, now looking at this contour lines, all of us know what are contour lines. Contour lines are the lines joining point of equal elevation. Yes, mainly in geology they are dotted as in the geological maps rather they are drawn as dotted lines. Yes, so these are the dotted lines that resemble the contour values. The shape resembles, the shape talks about what the contour, what the structure is. This is a W plunging anticline because these are the fold, these are the limbs, and this is the axis again, which is bend. Why it is bent? It is coming closer here. That is why the elliptical shape, because the axis is also plunging. It is going down now. So I just draw it with another color so that it is more prominent. This is the axis of the fold, and it is plunging. Getting me? Sorry, and it is plunging. And see, looking at the structure, actually you cannot talk what the structure is. Looking at the contours only, you got to be having the values. This is say 900 meters, 800 meters, 700 meters, and you have one more contour which is not continuous. This is just going away like this. Meaning it is not completely encircling the crest of the anticline. It is going away. Alright. So you have one more contour, or again one more contour, which is going away. Contour, which is not completely encircling the crest of the anticline. This is the crest of the anticline. Yeah. Now above 900 meters, you will have one value, that is 1000 meter. Yeah. Now in between 1900, one value exists, that is 950. and therefore see, you don't know where exactly 1000 meters contour is. Yeah, therefore you just take a center point of this structure and you mark it as 950 meters. Why? Because in between 900 and 1000 you are going to get 950 meters somewhere, right? Therefore you just take the center point and you take it as 950 meters. That is the crest of the anticline. Alright, so the crest of the anticline is this. You have three contours, say 1, 2 and 3 contours that completely encircle the crest of the anticline. The other two, now see this, the other two, they are not completely encircling the crest of the anticline, they are going away, correct? So we have only 3 contours that are completely encircling the crest of the anticline. So by formula, if we know, if you want to find out what closure is going to be the number of contours that completely encircle the crest of the anticline multiplied by the contour interval. Yes. So, what is the contour interval? 900 meters to 800 meters is 100. 800 meters to 700 meters is 100 meters again. 700 meters to 600 meters is 100 meters again. We are going down now. Therefore, I am reducing the values. From 600 meters to 500 meters is again 100 meters. Yeah. So, the difference is 100 meters. Ci is how much? 100 meters. So, you get contour interval is 100 meters. And number of contours that completely encircle the crest of the anticline is how much? 3. 1, 2, 3. So you write it as 3. Yeah. Multiplied. So you get closure as 300 meters. Getting me? Very easy like this. Yeah. So very first thing, you just look at the structure. You know this is abruptly plunging anticline by looking at the shape of the contours and the values of the contours. Without the values, you cannot say if it is a dome or a basin or what the structure is, right? So you got to look at this. If the values are increasing towards the center, it is a domal structure. If they are decreasing towards the center, that means it is a depression or a basin. Fine. Alright. So we have calculated what closure is. Closure is what here? The structural closure of this doubly plunging anticline is 300 meters. Now after having calculated the closure, the structural closure of this doubly plunging anticline, what we do is we have to mark the lower boundary of the closed area. Yeah. For that, I make use of the other color. Yeah. How do you mark the lower boundary of the closed area? What is closed area? I said closed area is the area where anywhere you drill, you are going to get hydrocarbons. Correct? Yeah. So if you remember in this doubly plunging anticline, when I was talking about this, I said from this point to this point. Yeah, say this is the closure, and closed area is nothing but anywhere you drill here in this place. Anywhere you drill here from this point to this point and horizontally, yes, from this point to this point, horizontally, anywhere you drill in this area, okay, now elliptical, these are going to be elliptical. Why? Because this side the axis is more, this side it is less. You getting me? The contour values, if I am talking about the levels, now you getting me? Please understand. See this side, see suppose this is 1000, okay, this is 900 here, 900 here, 900 here. So automatically you are going to get elliptical contours. You understanding? Automatically you are going to get elliptical contours. Say 1000 here, 900 here, 900 here, 900, 900. Correct? 4 points. 800, 800, 800, 800. Correct? 800 here again, 4 points. And several other points in between for 800. So the contours are automatically going to be elliptical for the domal structure here. I hope it is very clear to you now. For the contour lines and the shape of the domal structure, and why do we have specific contour shape of contour lines varying as per the structure. Fine. So the shape of this contour line, you guys know what is it, because it is a doubly plunging anticline. It is elliptical. For domal structure, basically the contours are going to be circular because on all the sides it has equal dip kind of. Fine. Alright. But this is roughly I am saying domal just because it is coming up. That is right. Alright, so coming back again to, so what is closed area? Closed area is from this point to this point, yeah. Horizontally anywhere you drill, and in this case up till here only, yeah. So anywhere you drill, you are going to get hydrocarbons. That is what is closed area. You have to find out the lower boundary of the closed area. How do you do that? You know what is the closure? Yes, I told you it is vertical dimension, right? From here, right from the center, from here till here. That is what is closure. So now what is happening is, when you have axis that is dipping, yes, and closed area is going to be the boundary, anywhere you drill, I am saying. So what you do is, from the crest of the anticline, you come down by the closure, you calculate with the closure, correct? So you just come down by that value. How much is the closure? Closure is 300 meters. Therefore what you do is you come down by 300 meters. So from 950 meters you come down by 300, that is 850, 750, 650 meters. So at 650 meters, in between 700 and 600, you are going to get a control value of 650 meters. Getting me? Yes? So this is your lower boundary of closed area, correct? Yeah. So you know what is closure, you know what is lower boundary of closed area, and you understood what is, what is the definition of closed area. Fine. So this is pertaining to a doubly plunging anticline. We've understood what is closure, we've understood what is closed area, and we know how to calculate the closure. Calculating is very easy. We just have to find out the number of contours that is completely encircling the crest of the anticline, and then you will come down by those values. For example, here I said number of contours. I did not say it is there. It is specifically it is drawn that you have 3 contours that are completely encircling the crest of the anticline. Therefore, what you do is you come down by 300 meters, and therefore and 300 meters 950. I said is a center point because it is center point, and higher value is going to be 1000 above 900, but we don't know where exactly it is lying, right? Therefore what we do is you take highest point at the crest of the anticline is 950 meters, and from 950 meters you come down at 850, 850 to 750, 750 to 650 meters, correct? And this is how you find the lower boundary of the closed area, and you know what is closure and closed area now. So I think we'll yeah, so we'll stop you for now, and let's see, I don't know if this video is being recorded actually, that because year before also I tried, and this is the second time I am repeating the same thing again, but I really don't mind it because I love to teach. So let's see further. I don't know if it is going to be recorded. If it is so, and if I find it good, I'm going to upload this. Yeah, fine. All the best and do well, guys. Thank you. Have a wonderful evening.